So before we begin talking about the differences between enols and enolates, we need to talk about alpha carbons. So it's just the carbon next to our carbonyl. So that's what our alpha carbon is. All right, so let's talk about enols and enolates. So we form enols under acidic conditions. And so the first step would be to protonate our carbonyl. So our lone pairs of electrons on our oxygen is going to reach out and grab this hydrogen. And so what we end up is basically a hydrogen connected to our oxygen. So next, our water is going to act as our nucleophile. So these lone pairs are going to reach out and going to grab this hydrogen. So after it's reached out and grabbed these hydrogens, these electrons here are going to move up and essentially form a double bond between our alpha carbon and where our carbonyl used to be. So we'll end up with a product that looks like this. So we'll have a double bond be formed between our alpha carbon and where our carbonyl used to be, which is right there. And this is our enol product, and this can actually go and be a nucleophile in aldol reactions. So now let's move on to our enolate. So our base, our OH, is gonna come and attack this hydrogen and remove it. And so these electrons here are going to essentially move on top of this carbon here. And so what it looks like, I'm going to draw you what it looks like in parentheses. So basically we have these electrons right on top of this carbon. And so what these electrons can then do is it can form a double bond. So once we form our double bond between our alpha carbon and our carbonyl, this carbon right here would then have too many bonds. And so what's going to happen is this pi bond right here I hope that's clear, but basically our pi bond is going to break. And once the pi bond breaks, these electrons are going to then move on top of this oxygen. So let me show you what that product will look like. So we'll form a double bond between our alpha carbon and where our carbonyl is going to be. And then that pi bond is going to break, and now we'll have these electrons move on top of our oxygen, yielding our final product.